From 4 billion miles away, Earth is a single, pale blue pixel in the emptiness. This iconic image reveals our world as a fragile speck, yet it also captures a profound emotional truth about our place in the cosmos. The universe is a vast, silent symphony of light and gravity, and for centuries, artists have been its essential interpreters. Humanity's oldest stories are written in the stars, from prehistoric caves to the digital screens of today. By the end of this journey, you will see how the mysteries of space are actively fueling a creative revolution across every modern art form. We will uncover how black holes are painted and why the sun's light dictates an artist's color palette. How does the infinite void above truly shape the finite canvas below? Deep within the Lascaux caves, a bison painted 17,000 years ago may hold a secret far above the earthly hunt. Some researchers see in the dots and shapes surrounding these animals not random splatters, but a map of the Pleiades star cluster. This suggests our first artistic impulses were not just to depict the land, but to capture the sky. Long before telescopes, our ancestors were already in a profound dialogue with the cosmos, using art to document the movements of the sun, moon, and stars. They transformed the overwhelming mystery of the night into stories and symbols, creating humanity's first celestial inspirations. This relationship between art and astronomy is physically etched into the landscape itself. An archaeoastronomer might point to Stonehenge, that great ring of standing stones on the English plain. It is not merely a monument, it is a sophisticated astronomical observatory designed to mark the solstices. At dawn on the summer solstice, the sun rises precisely over the heel stone, flooding the central altar with light. It is a perfect fusion of engineering, art, and celestial observation, a massive stone canvas for the sun's yearly dance. This cosmic artistry blossomed across ancient cultures. The Babylonians meticulously charted the paths of planets on clay tablets, creating the first known star catalogues. The Egyptians wove their solar deities into every facet of art, from the golden funerary mask of Tutankhamun to the towering obelisks that reached for the sun god Ra. The Mayans built elaborate temples that doubled as calendars, their facades and stairways aligned to cast specific shadows on equinoxes, turning architecture into a live display of cosmic order. One of the most stunning examples of this ancient synergy is the Nebula sky disk. Crafted in the Bronze Age over 3,600 years ago, this bronze disk is inlaid with gold symbols representing a crescent moon, the sun or full moon, and a cluster of stars thought to be the Pleiades. It is the oldest known concrete depiction of the cosmos, a portable masterpiece of both technical skill and artistic vision. What primal fears and wonders did our ancestors translate into their starry art? They saw the cosmos not as a cold void, but as a living narrative, a divine clockwork that governed the seasons, the harvests, and their very lives. Their art was a way to reach into that mystery, to find patterns in the chaos, and to place themselves within a grand celestial story. This deep-seated human need to artistically connect with the heavens would not disappear. It was merely waiting for a new age of discovery to reawaken it. Galileo Galilei's hand moved across the page, translating the jagged shadows in his telescope's lens into the very first detailed map of the lunar surface. In that moment, the roles of scientist and artist became indistinguishable. This was the spirit of the Renaissance, a time when the rediscovery of the heavens ignited a parallel revolution in art. As the art historian E. H. Gombrich noted, the newfound understanding of a structured, knowable cosmos directly influenced how painters composed their work, seeking a divine balance that mirrored the celestial order. Artists were no longer just illustrating biblical scenes. They were investigating the physical world with the same fervent curiosity as astronomers. Leonardo da Vinci filled his notebooks with studies of light and shadow, dissecting the nature of luminosity with a precision that could chart the phases of the moon. Albrecht Dürer produced incredibly detailed star maps, merging artistic skill with scientific observation to chart the constellations. This convergence is visible in the very architecture of Renaissance painting. The invention of linear perspective allowed artists to construct vast, rational spaces on flat walls, creating heavenly vaults that seemed to recede into infinity. In allegorical works, planets were personified as gods and goddesses, their symbolic presence governing the narratives of human fate. Nowhere is this cosmic ambition more breathtakingly clear than on the ceiling of the Sistine Chapel. Michelangelo's monumental fresco does not merely depict biblical figures, it visualizes the cosmos itself. The panel showing the separation of light from darkness presents God as a titanic force of cosmic creation, his form swirling within the primal chaos of the universe. This was art striving to depict the mechanics of Genesis, so we must ask, how did the shattering realization of a heliocentric universe with the sun, not the earth, at the center, reshape the artist's sacred role as an interpreter of divine order? It shifted the very foundation of their purpose. The artist became a mediator between a new, disorienting cosmic truth and the human need for meaning. This intellectual upheaval, however, would soon give way to a different kind of celestial inspiration, one not of the mind but of the heart. A solitary figure stands on a rocky crag, his back to us as he gazes at a misty, moonlit sky. In Caspar David Friedrich's famous painting, the human form is dwarfed not by a church or a king, but by the cosmos itself. This image is the very essence of the Romantic movement of the 19th century, a profound shift where artists turned from the rational order of the Renaissance to embrace the raw, emotional awe of the universe. The poet William Wordsworth captured this new feeling perfectly, writing of the stars that have another birth. For the Romantics, the cosmos was not a clockwork mechanism to be understood, but a sublime mystery to be felt. They sought to capture the overwhelming sensation of standing before the infinite, a mixture of wonder, terror, and a beautiful melancholy that came from understanding our own small place in it all. Their canvases became stages for celestial drama. Comets streaked across the sky not as predictable astronomical events, but as fiery omens of change. The diffuse band of the Milky Way was painted as a shimmering river of souls, a pathway to eternity, and the moon, no longer just a rock in space, became a melancholic muse, its pale light illuminating lonely landscapes and stirring feelings of longing and solitude. J.M.W. Turner's Seascapes and Skies are a masterclass in this approach. His paintings are often a whirlwind of color and light, where the sun struggles to break through tumultuous clouds and storms. He wasn't documenting the weather, he was capturing the very energy of the atmosphere, the chaotic and beautiful force of nature that felt both cosmic and deeply personal. So we are left with a powerful question. Can art truly capture the feeling of staring into the abyss? The Romantics believed it could, by translating the vastness of space into a language of human emotion. This profound desire to feel the cosmos, however, would soon meet a new invention that promised not just to feel it, but to objectively see it for the very first time. John William Draper's daguerreotype of the moon from 1840 is a faint, ghostly imprint on a silver plate. It is blurred and indistinct, yet it marks a revolution. For the first time in human history, the light of a celestial body was captured not by a human hand with a brush, but by chemistry and optics. This was the birth of astrophotography, a technology that promised pure objectivity, a mechanical eye that would see the heavens without the filter of human emotion. A historian of science might describe this moment as a great demystification. The moon was no longer just a symbol in a poem or a deity in the sky. It was a physical place with craters and plains, rendered by the cool, impartial eye of the camera. Yet, in stripping away the myth, photography added a new, profound layer of mystery. It revealed a cosmos far richer and more detailed than our eyes could ever perceive. The key to this new vision was the long exposure. While our eyes can only gather light for a fraction of a second, early photographic plates could accumulate light for minutes or even hours. This patient process unveiled a hidden universe, faint, wispy clouds of gas that were mere smudges in a telescope's eyepiece resolved into vast, intricate structures on the glass plate. Stars too dim for human sight left their permanent marks, transforming empty blackness into a crowded stellar city. This was a new art form, one that merged the technical skill of the astronomer with the compositional eye of the artist, carefully framing the cosmos within the square boundaries of the plate. The process was fraught with difficulty. Early photographic emulsions were terribly insensitive. Telescopes had to track their targets with perfect precision for long periods, a mechanical challenge in an age of clockwork and gears. Observatories became the new workshops for this cosmic art, their great domes housing both the scientist's instrument and the artist's new brush, and the public was captivated. When the first photograph of the Great Nebula in Orion was published, it caused a sensation. Here was a celestial object known for centuries, but now seen with a clarity and ethereal beauty that was both shockingly real and utterly dreamlike. Its swirling clouds of luminescent gas looked less like a distant object and more like a gateway to another dimension, so we are left to ponder a compelling question. Did the camera's objective eye make the cosmos feel more real and tangible, or did its ability to reveal these impossibly beautiful, ghostly forms make the heavens feel more alien and dreamlike than ever before? This technological bridge, capturing literal light from the stars, would directly inspire the next great artistic movement to turn its gaze upward. Wassily Kandinsky sat in a dark room, listening to the soaring notes of an opera. He did not see a stage or a singer, he saw color and form. He believed he was painting the spiritual vibrations of the cosmos itself, translating the music of the spheres into the first purely abstract artworks. This was the dawn of the 20th century, a time of radical upheaval. Modernist artists were shattering the centuries-old tradition of representation. They were no longer trying to paint the night sky as it appeared, but as it felt, the unseen forces of the universe channeled through form, color, and line alone. Kandinsky described his process in almost mystical terms, writing, "Color is the keyboard, the eyes are the hammers, the soul is the piano with many strings." For him, art was a direct conduit to cosmic truth, a way to make the invisible energies of existence visible on the canvas. This philosophical shift was happening in tandem with a scientific one. Albert Einstein's theories of relativity were rewriting the very definitions of space and time. The universe was no longer a static stage with fixed laws, but a flexible, dynamic fabric where space could bend and time could slow. This new, mind-bending reality demanded a new artistic language. Artists began to explore this cosmic fluidity. Joan Miro populated his paintings with biomorphic shapes and cosmic constellations, creating playful yet profound maps of an alternate universe. The abstract expressionists took this quest even further. Their massive canvases became arenas for primal, cosmic acts. They used chaotic splatters to mirror the violent birth of a star, vast fields of radiant color to evoke the silent emptiness between galaxies, and swirling, energetic spirals to capture the dynamic motion of nebulae. No artist exemplifies this raw, cosmic expression better than Jackson Pollock. His famous drip paintings were not mere accidents. He would lay a vast canvas on the floor and move around it, pouring and flicking paint in a rhythmic, almost ritualistic dance. The resulting webs of interlacing lines have been interpreted as maps of cosmic chaos, the tangled structure of the universe at its most fundamental level. Some scientists have even noted a striking resemblance between his intricate paint splatters and the complex, fractal patterns seen in everything from neural networks to cosmic web structures of dark matter. So we must ask, is abstract art the purest form of translating the universe's unseen forces? By stripping away the recognizable world, these artists attempted to connect directly with the underlying energy and structure of reality itself. This profound, internal exploration of the cosmos was about to collide with a very external, very public event, an event that would launch art itself into a new frontier. Andy Warhol's silkscreen of an astronaut, repeated like a can of soup, perfectly captures the strange new reality of the space race. The cosmos had entered the living room. Throughout the 1950s and 60s, the frantic competition to conquer space became a constant presence in popular culture, broadcast directly into homes through the new medium of television. As media theorist Marshall McLuhan famously observed, this instant worldwide communication was creating a global village, and the astronaut was its newest, most glamorous citizen. Art could no longer respond with pure abstraction or romantic awe. It had to grapple with a cosmos that was now branded, politicized, and sold. Pop art stepped into this role with irony and bright commercial color. It took the celestial iconography of rockets and planets and reproduced it with the same mechanical detachment used to print comic books and product labels. Roy Lichtenstein's paintings are a perfect example. His comic-style explosions, with their bold outlines and Ben-Day dots, look less like earthly fireballs and more like a stylized supernova, a cosmic event reduced to a cheap, reproducible graphic. This was not merely celebration, it was a sharp commentary on how even the grandest human endeavor was being commodified, turned into just another product for mass consumption. On the other side of the Iron Curtain, a different kind of cosmic art was flourishing. Soviet space propaganda posters presented the cosmonaut as a heroic, state-sanctioned pioneer. These works were not ironic, they were intensely idealistic, using a bold, graphic style to fuse communist ideology with the epic narrative of space exploration. They were art in the service of a national mission. This tension between idealized heroism and commercial reality is beautifully crystallized in Norman Rockwell's painting, A New World. Created in close collaboration with astronauts, it presents a stunningly realistic vision of a spacewalker floating in a serene, star-dusted void. It is both a technical masterpiece and a deeply romantic image, a testament to human courage that somehow feels separate from the political frenzy below. So we are left to ponder a compelling question. Did the art of this era glorify the space race, or did it subtly reveal the underlying commercial and political engines that powered it? By placing the astronaut alongside celebrities and consumer goods, pop art held up a mirror to a society that was learning to sell the stars themselves. This fusion of cosmic ambition and mass media would seamlessly flow into the next great shift as the artist's canvas transformed once again, this time into the infinite space of the digital screen. A digital artist types a line of code and a star is born. With another command, an entire spiral galaxy swirls into existence on the screen, a cosmic structure that has never been seen before and will never appear again in exactly the same way. Here, in the late 20th and 21st centuries, the artist's studio has transformed. The canvas is the luminous screen, and the brush is a string of algorithms. Code has become the new medium for celestial expression, allowing creators to paint with the raw data of the universe itself. As one digital programmer explains, we are no longer just looking at pictures of space. We are using the actual information from telescopes like Hubble as our pigment. This data, the light from distant stars and galaxies, is the raw material for a new artistic revolution. This practice is known as generative art, where the artist designs a system or a set of rules, and then lets that system run to create unique, often unpredictable, visual outcomes. It is a collaboration between human intention and computational process. Artists are feeding massive cosmic data sets into sophisticated software, generating breathtaking visualizations of phenomena we can never directly photograph. They craft three-dimensional models of hypothetical exoplanet surfaces based on atmospheric data. They map the invisible gravitational pull of dark matter, making the cosmic web visible as a vast, intricate structure. They simulate violent galactic collisions over billions of years, all within the memory of a computer. To create the ethereal clouds of a nebula, an artist might use a particle system, where millions of individual digital points are born, move, and fade according to the laws of physics coded by the artist, mimicking the turbulent gas and dust of a stellar nursery. And with virtual reality, this art becomes an environment you can step inside, an immersive experience of floating past asteroid fields or witnessing the birth of a star from its center. Consider the work of Rafik Anadol, who uses artificial intelligence to process millions of data points from NASA archives about Mars. He transforms this information into flowing, architectural-scale data sculptures, projections that wash over buildings in waves of color and form that are directly derived from the Martian landscape. It is not a painting of Mars, it is a data portrait of the planet, a visual symphony composed from its own scientific record. This leads us to a profound and unsettling question. When an artist writes the code that gives birth to a digital universe, who is the true creator? Is it the programmer who designed the system, or is it the system itself following its own emergent logic? This digital foray into the cosmos, this act of painting with pure information, is fundamentally an exploration conducted with one essential ingredient. Light itself becomes the paint on an invisible canvas. A visitor steps into a dark room that suddenly floods with the shimmering, ethereal dance of an aurora. Greens and purples pulse across the walls and floor, washing over their skin, making them feel as if they are standing not in a gallery, but inside the upper atmosphere of a distant planet. This is the power of light art, a medium that directly channels the most fundamental force of the cosmos. Artists are now sculpting with photons, using LEDs, lasers, and vast projections to mimic the birth of stars, the violent flash of a supernova, or the magnetic fury of a solar flare. The master of this approach, James Turrell, describes his intent by saying, "I want to create an atmosphere that can be consciously plumbed with seeing." He is not simply showing you light. He is creating an environment made of light for you to physically inhabit and explore with your senses. This requires immense technical precision. To convincingly evoke a cosmic event, an artist must control every aspect of the light, its color temperature, its intensity, its duration, and its interaction with mist or smoke. A single shade of blue can mean the difference between the cold void of deep space and the energized glow of a nearby nebula. these choices have a direct psychological impact. Warm golden light can feel nurturing, like a nearby sun, while a sudden, sharp flash of white can trigger a visceral shock, mimicking the awe and terror of witnessing a stellar explosion from afar. A legendary example of this transformative power is Olafur Eliasson's The Weather Project at the Tate Modern. He installed a massive, circular array of monochromatic lamps behind a fine mist, creating a hauntingly beautiful artificial sun that dominated the hall. Visitors would lie on the floor for hours, mesmerized, their sense of scale and reality completely altered by this manufactured celestial body. It forced us to ask a deeply personal question. Can this carefully engineered, artificial light ever evoke the same primal, soul-stirring awe we feel when looking up at a real, distant star? Or does its human origin create a different, more intimate kind of wonder? This exploration of cosmic energy through pure sensory experience naturally extends beyond the visual into a realm we cannot see but can only hear. A pulsar's rhythmic radio waves translated into sound create an eerie metallic melody, a cosmic heartbeat billions of years old. This process, called data sonification, turns the invisible energy of the cosmos into a symphony we can actually hear. It is the foundation of an entire genre known as space music, a form of ambient and electronic composition designed to evoke the profound feelings of vastness, mystery, and interstellar travel. The composer Brian Eno, a pioneer of this field, described his goal as creating sonic landscapes, environments of sound that are as ignorable as they are interesting. He was not writing songs for us to follow, but building vast auditory spaces for us to inhabit, to get lost in, just as we might gaze into the starry void. Artists construct these cosmic soundscapes using tools that seem to defy gravity itself. Synthesizers generate shimmering pads and deep, rumbling drones that have no earthly origin. The theremin, played without physical contact, produces its signature ethereal wail, a voice that feels both alien and deeply melancholic. Inside digital audio workstations, composers layer these sounds into complex textures, stretching time and pitch to create a sensation of infinite scale and slow, celestial motion. The source material for these compositions is often the cosmos itself. Artists incorporate field recordings from NASA missions, like the haunting chorus of charged particles trapped in Jupiter's powerful magnetosphere, a sound both beautiful and terrifying. They use algorithmic composition, writing code that translates astronomical data, such as the orbital periods of exoplanets or the light curves of variable stars, directly into musical notes and rhythms. The band Tangerine Dream perfected this approach in the 1970s and 80s. Their epic electronic suites built on sequencer patterns that pulsed like spinning pulsars and synth melodies that soared like comets. Their music became synonymous with cosmic journeys, providing the sonic backdrop for films that explored the final frontier. So we must ask, what does the silence of space sound like when translated into music? It is not empty at all, but a rich tapestry of vibration and rhythm, a hidden symphony waiting for its artists. This auditory exploration of the heavens naturally leads us to the most immersive medium of all, where sight and sound combine to tell the ultimate cosmic stories on the silver screen. The silver screen transforms the cosmos into a grand stage for the human drama. Kubrick's Stargate sequence in 2001, A Space Odyssey, is not a traditional narrative. It is a visceral, psychedelic journey through light, color, and form that redefined what cinema could say about the universe. Film became the ultimate narrative medium for space, using its infinite backdrop to explore our deepest fears and highest aspirations about adventure, isolation, and our own existential place in the grand scheme. Director Christopher Nolan articulated this pursuit of authenticity, stating his team used practical effects and real scientific equations to render the black hole in Interstellar. The result was not just a visual effect, it was a profound artistic statement, a swirling, luminous accretion disk that felt terrifyingly real and beautiful. This commitment to a believable cosmos rests on a trinity of cinematic crafts. Special effects, whether practical or digital, build the physics of these worlds. Production design defines their texture and history, from the used, lived-in future of Alien to the sterile majesty of a rotating space station. And cinematography paints it all with light, determining how a distant sun illuminates an alien landscape or the absolute blackness of space swallows a lone astronaut. Consider the artistry behind the color palette of an alien world. A planet with a dying red sun might be bathed in perpetual, haunting twilight, using deep crimsons and umbers to evoke a sense of cosmic melancholy. The vibrant, toxic greens and yellows of a jungle moon immediately signal a world teeming with unknown life. Before the dominance of computer-generated imagery, model makers were the unsung heroes of cosmic cinema. They meticulously constructed miniature fleets of starships and entire space stations, filming them with painstaking motion control photography to create the epic battles in Star Wars, giving a tangible, physical weight to the fantasy. Today, CGI allows artists to simulate the impossible, to choreograph the birth of a star or the mind-bending topology of a wormhole, phenomena that exist only in theory and mathematics. The film Gravity stands as a masterclass in this synthesis. Its long, fluid shots create an uninterrupted, immersive ballet of terror and beauty, perfectly illustrating the unforgiving nature of orbital mechanics. The silent, violent detachment of a space station becomes a heart-stopping moment of pure cinematic poetry, emphasizing the profound fragility of a single life adrift in the infinite. So we must ask, do these grand space films truly show us a future among the stars, or do they ultimately hold a mirror to who we are right now, projecting our earthly hopes, political anxieties, and philosophical questions onto the vast canvas of the void? This immersive, large-scale storytelling finds a powerful counterpoint in an art form that is just as ambitious, but exists in three-dimensional, tangible space. Your own reflection stares back at you from a curved, liquid-like surface, the city skyline and clouds above warping into a seamless celestial orb. This is Anish Kapoor's Cloud Gate in Chicago, a sculpture that does not simply sit in a plaza but actively engages the heavens. Its mirrored surface captures and distorts the sky, turning every passerby into a temporary participant in a cosmic dance. Sculpture and installation art create a unique, physical encounter with ideas of the infinite. You do not just look at these works, you move around and through them, experiencing concepts like scale and gravity with your entire body. The legendary architect Zaha Hadid captured this spirit, explaining that her design sought to emulate the organic, flowing logic found in nature and, by extension, the cosmos. Her buildings, with their sweeping, gravity-defying curves and fluid spaces, feel less like static structures and more like fragments of a galactic nebula frozen in steel and concrete. Sculptors working with cosmic themes face a fascinating challenge: how to represent the unimaginable vastness of the universe within the confined space of a gallery or a public square. They manipulate materials like polished steel to create endless reflections, suggesting infinite regress. They suspend intricate networks of glass rods to map the invisible paths of orbiting planets. They use taut wires and heavy spheres to make the abstract force of gravity tangible and visible. To overcome the problem of scale, artists often turn to the miniature, crafting a meticulously beaded model of the solar system where a single, tiny pearl becomes the Earth, forcing a visceral understanding of our smallness. Others use kinetic elements, setting polished spheres into slow, perpetual motion around a central core, a silent ballet that mimics the orbital mechanics governing our solar system. A powerful example of this three-dimensional cosmic thinking is Tomas Sarasno's Erosine project. He creates enormous floating sculptures, delicate membranes that look like cosmic jellyfish or new forms of life. These sculptures are designed to float using only the heat of the sun and the air we breathe, riding atmospheric currents with no engines, no fuel, and no emissions. They are not just sculptures, they are prototypes for a new relationship with our planet, envisioning a future of atmospheric exploration and habitation that is in perfect harmony with the Earth's systems. So, how does walking through a sculpture change our bodily understanding of space? It transforms an intellectual concept into a physical reality. You feel the curve of a wall that represents a planet's horizon. You duck under a hanging sphere that symbolizes a dying star. You see your own tiny form reflected back from a surface that represents the infinite. This direct, physical engagement with cosmic ideas creates a bridge between the individual and the universe, a bridge that is built not just by the artist alone, but through a profound collaboration with the very scientists who are mapping the cosmos. A painter stood in the clean room at Cape Canaveral, watching engineers prepare a satellite for launch. Robert Rauschenberg, a giant of the pop art movement, had been invited by NASA in the late 1960s to witness the Apollo missions firsthand. This unprecedented access was not for publicity but for inspiration. The result was his Stoned Moon series, where he combined technical diagrams, launch photography, and his own expressive brushwork, fusing the mechanical precision of the rocket with the raw, human gesture of the artist. This was one of the first great artist-scientist collaborations of the modern era, a model that has since blossomed into a profound symbiosis. Today, institutions like CERN, the European Organization for Nuclear Research, and NASA Jet Propulsion Laboratory run formal artist residency programs. They open their doors, their data, and their minds, inviting creators to use particle accelerators and deep space telescopes as their studios. A senior scientist at CERN might explain that artists ask questions they would never think to ask. They look at the intricate data trails of subatomic collisions and see not just evidence for a theory, but patterns of immense beauty and philosophical weight. They offer a new lens, one that is unburdened by the strict methodology of the scientific process, yet deeply respectful of its truths. The benefits of this partnership flow in both directions. Artists gain access to the very frontier of human knowledge, to concepts and imagery that would otherwise remain locked away in academic papers. They work with satellite data streams, turning the Earth's vital signs into pulsating digital maps. They create installations that attempt to give form to the bizarre, probabilistic world of quantum mechanics, where a particle can be in two places at once. In return, scientists gain a powerful set of communicative and interpretive tools. An artist can transform a dense, multivariate data set on climate change into an immersive, emotional experience that a graph never could. They help translate the abstract grandeur of a concept like multiverse theory into something the public can not only understand but feel in their bones. One of the most stunning successes of this model came years before the Event Horizon Telescope captured its famous image of the black hole in Galaxy M87. For the Black Hole Project, a team of artists worked directly with astrophysicists to create visualizations based solely on the mathematical equations of general relativity. They weren't guessing what a black hole might look like. They were painting with the very laws of physics, rendering the warping of space-time and the terrifying glow of its accretion disk with scientific fidelity. Their work prepared the public eye for the real thing, building a visual language for a phenomenon that had only existed in theory. So we are left to ponder a crucial question about this relationship. In this collaboration, is the artist a translator, a colleague, or a provocateur? Perhaps they are all three at once, a necessary bridge between the raw data of the cosmos and the human heart that seeks to find meaning within it. This powerful fusion of disciplines, nurtured within the halls of great institutions, inevitably spills outward, seeking to transform not just galleries, but the very streets we walk. The domed ceiling above you dissolves into a perfect, star-dusted replica of the Milky Way, lying back in the dark, surrounded by the silent, swirling galaxy. The experience is less a lesson and more a feeling, a visceral connection to the scale and beauty of the cosmos. This is the Modern Planetarium, a sanctuary where celestial art is curated for a collective, awe-inspiring experience. Museums, galleries, and these very domes have become essential interpreters, framing the cosmos not just as a subject for science, but as the source of profound artistic expression. A planetarium director might describe this evolution, noting how their programming has shifted from straightforward astronomy lectures to fully immersive, artist-led journeys that blend visual spectacle with atmospheric soundscapes. These institutions actively commission new works from digital artists and composers, building exhibitions with themes like the art of nebulas or the sound of pulsars. They are not merely displaying art, they are engineering holistic, multi-sensory environments. Exhibition designers labor over the precise quality of light, using carefully calibrated LEDs to mimic the cool, distant twinkle of starlight, avoiding the warm glow of ordinary bulbs that would shatter the cosmic illusion. Sound engineers compose intricate audio tracks that fill the space with the deep, resonant hum of interstellar space or the subtle, melodic clicks of a passing meteor shower. Educational programs seamlessly merge disciplines, inviting children to paint based on images from the James Webb Space Telescope or leading workshops on the geometry of planetary orbits. A prime example of this synthesis is the Hayden Planetarium at the American Museum of Natural History. For its famous space shows, the planetarium frequently partners with visual artists and musicians, transforming raw astrophysical data into breathtaking narrative journeys through the universe. The final product is a seamless fusion of scientific visualization and artistic interpretation, where the birth of a star is both a nuclear process and a ballet of light. So we must ask, is a modern planetarium more a theater of art or a classroom of science? It has transcended that binary, becoming a hybrid space for wonder, a public forum where the cosmos is felt as much as it is understood. This public, curated encounter with the celestial naturally inspires a much more personal and intimate response, one that begins with a simple, accessible tool. A physics textbook lies open next to a palette splattered with ultramarine and violet. In this studio, the tools of science and art exist in a state of creative tension, a partnership dedicated to a single, monumental task, translating the infinite wonder of the cosmos into a finite, tangible form. The journey from that initial spark of awe to the final stroke on the canvas is a deeply personal alchemy. It begins with a daily ritual of looking up. One contemporary space artist describes their non-negotiable routine of pre-dawn stargazing, a quiet communion that clears the mind and fills the creative well. They say, the silence and the scale reset my perspective. I am not just making a picture, I am trying to bottle a feeling, the feeling of being a tiny, conscious part of something impossibly vast. This feeling is the fuel, but the path from inspiration to execution is paved with profound challenges. The first and greatest hurdle is the problem of scale. How do you represent the sheer size of a nebula that would take a spacecraft thousands of years to cross, on a canvas that measures only a few feet. Artists wrestle with this constantly, using compositional tricks to imply infinite depth, placing a tiny, distant spacecraft in the corner to give the viewer a sense of the staggering distance. Another formidable challenge is color. The human eye cannot see the faint glow of many deep space objects as the Hubble or Webb telescopes do. So an artist must make a choice. Do they paint the scientific representation, using false color maps assigned to different elements like hydrogen and oxygen? Or do they invent an intuitive palette that feels true to the emotional essence of the scene? This leads to countless studies and sketches, small experiments on paper testing how cobalt blue interacts with a fiery magenta to evoke a stellar nursery. They experiment with new materials, mixing luminescent paints that charge under light and glow faintly in a dark room, or using resins and gels to build up thick, textured surfaces that mimic the chaotic topography of a galaxy. Then there is the emotional weight of depicting cosmic violence. Rendering a supernova is not merely an exercise in painting an explosion. It is an attempt to capture a star's death throes, a catastrophic event that seeds the universe with the very elements that make life possible. The artist must balance the terrifying fury of the event with a strange, terrible beauty, a recognition of destruction as a necessary creative force. We can see this meticulous process in the work of a digital artist crafting a three-dimensional galaxy. They do not simply paint a spiral shape, they build it from the ground up, layer by layer. First comes the core, a dense ball of ancient stars. Then they painstakingly add individual star fields, scattering millions of tiny points of light to create the galaxy's arms. Next, they use complex software brushes to paint in the delicate, wispy clouds of cosmic dust, carefully adjusting their transparency to create a convincing sense of depth. They add glowing nebulae as separate elements, texturing them with turbulent noise patterns to simulate the churning gas. This entire digital sculpture is then lit by a virtual sun, its light calculated to cast accurate shadows across the spiral arms, a process that can take hundreds of hours to achieve a single, believable image. All of this labor, from the traditional painter's sketches to the digital artist's layers, forces us to ask a fundamental question. What is more important in cosmic art, factual correctness or emotional truth? Is a perfectly rendered, scientifically accurate depiction of a black hole more valuable than an abstract splash of color that genuinely makes someone feel the sublime terror of the void? This intimate look behind the curtain at the research, the struggle, and the choices reveals that the artist's studio is a laboratory for human wonder. It prepares us to see the specific cosmic subjects they tackle not as simple pictures, but as profound philosophical inquiries made visible. A total solar eclipse plunges the world into an eerie twilight, and for a few breathless minutes, the sun is not a source of life, but a perfect black hole in the sky, ringed by a shimmering, ethereal corona. The sudden silence that falls over the land is as profound as the darkness, a sensory reset that has captivated and terrified artists since the first human witnessed this celestial alignment. Our closest star, the Sun, is the original creative muse, a force of dualities. It is the source of all life and warmth, yet it possesses the power for absolute obliteration. The philosopher Gaston Bachelard captured this perfectly when he wrote, "The sun is the first painter." It is the primordial artist that first taught us about light, shadow, and color, setting the very palette for our world. Artists have spent centuries trying to depict the sun's many faces, each interpretation revealing a different facet of our relationship with this colossal nuclear reactor. In the hands of the Impressionists, the sun became a nurturing presence. Claude Monet's series of the Houses of Parliament is a masterclass in this approach. The buildings themselves are mere silhouettes, vague forms dissolving into the London fog. The true subject is the sun, its light filtered through the polluted air, creating a breathtaking symphony of oranges, purples, and golds. Monet was not painting a place, he was painting an atmosphere, a moment of time defined entirely by the sun's fleeting interaction with the world. He faced the immense technical challenge of representing its blinding light not with pure white, but with a complex mixture of warm, vibrant color. This nurturing image stands in stark contrast to the sun in apocalyptic art, where it transforms into a terrifying, vengeful god. Here, it is a swollen red giant consuming the horizon or a harsh, white inferno bleaching a cracked desert landscape. These works tap into deep cultural memories of solar deities, from the demanding Ra of Egypt to the fierce Inti of the Inca, beings who demanded worship but could also bring drought and famine. In our modern era, a new vision has emerged, the sun as a complex magnetic entity. Data artists now use real-time information from solar observatories, translating sunspot cycles and solar flare activity into pulsating digital visualizations and intricate abstract patterns. The sun's surface becomes a dynamic, churning canvas of its own. So why does this star, a constant in our daily lives, remain an endless source of artistic mystery? Perhaps because it is the one celestial body we cannot look at directly, forcing us to always see it indirectly through its effects on our world and our imagination. Our artistic gaze, having wrestled with the nature of our local star, naturally expands to wander among its children, the enigmatic planets. The first grainy photographs from Mariner 4 were a cold shock to the artistic imagination. Mars was not a world of canals and ancient civilizations, but a barren, cratered desert, a dead world. This single transmission redefined our entire solar system from a collection of mythological symbols into a gallery of tangible, alien landscapes, each with a unique and challenging personality for any artist to capture. The planets are no longer just points of light, they are worlds. A planetary geologist might describe this shift, explaining how data from orbiters and rovers gives artists an ever-evolving palette. We no longer have to guess what the cloud tops of Jupiter look like. We have spectral data revealing their chemical composition, and topographic maps charting the violent flow of its storms. This hard data has catalyzed a profound artistic migration, away from depicting Mars as a god of war and Venus as a goddess of love, and toward rendering their actual physical realities. The artist's challenge now is to translate this torrent of information into a visual language that feels both true to the science and stirring to the human soul. Consider the violent beauty of Jupiter. Its great red spot is a colossal, spinning storm, an anticyclone larger than our entire planet that has raged for centuries. How do you paint something that is both a terrifying force of nature and a mesmerizingly intricate pattern of swirling ammonia clouds? An artist must balance the sheer scale, using contrasting colors to show the churning turbulence where different atmospheric bands meet. Then there are the icy plains of Europa, a moon cracked and streaked with reddish-brown scars. The artistic focus here is on texture, capturing the feeling of a vast, frozen ocean world. Its surface a fractured puzzle of ice rafts under the faint, cool light of a distant sun. The goal is to evoke the profound mystery of what might lie beneath that icy crust. And then there is Venus, a true test of artistic interpretation. Its surface is a hellish 760 degrees Celsius, shrouded under thick clouds of sulfuric acid. Radar data from missions like Magellan have mapped its terrain, revealing volcanoes and deformed highlands. An artist cannot paint this world with a traditional landscape approach. Instead, they might use a palette of scorched reds and oranges, depicting the scene through a heat haze, with the light diffused and oppressive, the very air feeling thick and heavy with poison. This new, data-driven artistry finds one of its purest expressions in the work of Michael Benson. He acts as a cosmic curator, sifting through millions of raw, black and white images from NASA planetary archives. He then painstakingly processes them, calibrating color based on scientific filters, stitching multiple frames together, and sharpening details to produce stunning, fine art photographs of planetary surfaces. His work is not invention, it is revelation, drawing out the inherent beauty that is already present in the data, waiting for a human eye to frame it. This forces us to confront a compelling question. As our probes and rovers get ever closer, mapping every mountain and valley, does the art of these worlds lose its mystery, or does it gain a new, more profound depth? The answer may lie in the realization that the more we know, the more we understand how much we have yet to feel. This detailed tour of our planetary neighborhood, from the fiery Jupiter to the frozen moons, is only the beginning. Our artistic gaze is now being pulled by an even stronger gravitational force toward the most enigmatic and powerful phenomena in the entire universe. A photograph from the Hubble Space Telescope reveals 3 towering columns of cold gas and dust soaring through the void like ghostly cathedral spires. This is the Pillars of Creation, an image so dense with intricate detail and ethereal color that it feels less like a scientific document and more like a vision from a divine artist. These structures are nebulas, the vast clouds of gas and dust that serve as both the cradles and the tombs for stars. They are perhaps the most visually spectacular and directly inspirational subjects for any artist looking to the cosmos. The astronomer Carl Sagan gave us the most profound reason for their pull on our imagination when he said, "The nitrogen in our DNA, the calcium in our teeth, the iron in our blood were made in the interiors of collapsing stars." We are not just looking at beautiful clouds, we are looking at our own distant, elemental origin. The beauty of a nebula is literally written in our bones. This deep connection fuels the artistic drive to interpret these cosmic structures, to translate their ethereal, fluid forms and impossibly vibrant palettes into a language we can feel. The artist's first great challenge is the nebula's sheer scale and diffuse structure. A single nebula can be light years across, a volume of space so immense that our entire solar system would be lost within it like a pebble in an ocean. How do you contain that on a canvas? Artists grapple with this by focusing on texture and light, using soft, bleeding edges and layers of translucent color to build up the cloud-like forms, suggesting a depth that extends far beyond the picture plane. The vibrant colors we see in telescope images present another fascinating dilemma. Many of these hues are false color, assigned by scientists to represent different elements like hydrogen, oxygen, and sulfur. So the artist must make a choice to follow the scientific map or to invent an intuitive color scheme that captures the emotional resonance of the scene. This often leads to the use of fluid painting techniques like acrylic pouring, where paints are mixed and poured onto the canvas, then tilted and manipulated to create organic, swirling patterns that perfectly mimic the turbulent, chaotic birth of stars within the gas clouds. The artist Vija Selmans approached this challenge from a different angle. Her early works included incredibly detailed, monochromatic drawings of nebulas, painstakingly rendered in graphite based on telescope photographs. By stripping away the color, she forced us to see the pure form and structure, the delicate filaments and overwhelming density of these cosmic clouds, translating astronomical data into a deeply personal, meditative act. So we are left to wonder, are nebulas the universe's most natural abstract expressionists? They are cosmic events of pure form and color, chaotic and beautiful in equal measure, existing long before any human hand attempted to capture their essence. This focus on the stellar nurseries, the places where stars are born, naturally compels us to witness the other side of that life cycle, their dramatic and violent end. The world held its breath in April 2019 as the Event Horizon Telescope collaboration unveiled the first direct image of a black hole. That fiery, lopsided ring of light, a perfect confirmation of Einstein's predictions, instantly became an icon. It was the ultimate paradox made visible, a picture of an object that, by its very definition, cannot be seen. A black hole is a region of space where gravity is so intense that nothing, not even light, can escape its pull. This presents the ultimate challenge for an artist. How do you paint the unseeable? Theoretical physicist Kip Thorne, who guided the stunning visuals for the film Interstellar, described the process as a tightrope walk between scientific imagination and artistic license. He noted that their goal was to visualize the warping of spacetime itself, to make the invisible forces of the universe a tangible, visceral experience for the audience. To meet this challenge, artists have developed a sophisticated visual language built on the effects a black hole has on its surroundings. The most prominent feature is the accretion disk, a swirling vortex of superheated gas and plasma spiraling inward at near light speed. This is the source of that iconic ring of fire, a cosmic hurricane of incandescent matter. Then there is the phenomenon of gravitational lensing. The black hole's immense gravity acts like a colossal lens, bending the very fabric of space and warping the light from stars and galaxies behind it. An artist painting this effect must distort the background star field into a perfect, shimmering ring around the central shadow, a halo of twisted reality. Some creators move beyond literal depiction into pure abstraction, using swirling brushstrokes, dark voids, and concentric circles to symbolize the profound curvature of space-time, the invisible geometry that dictates the motion of everything around it. This work often relies on complex computer simulations that solve the equations of general relativity, providing a mathematical scaffold for the artist's vision. Before the real image was ever captured, a major collaborative project between artists and astrophysicists did exactly that. They used supercomputers to visualize what a black hole should look like based purely on the mathematics of Einstein's theory, creating the public's first realistic expectation of this cosmic phantom. These visualizations are not just pretty pictures, they are tools for thought, helping scientists and the public alike grapple with the black hole's deeper implications. They become symbols of ultimate mystery, representing voids of nothingness, potential portals to other universes, and the mind-bending puzzles of information paradoxes, where the fundamental rules of physics seem to break down at the edge of infinity. So we are left with that haunting question: how do you give form to an object defined by its absence? You paint its shadow, you illustrate its violent embrace of light and matter, and in doing so, you give a human face to the most profound silence in the cosmos. This engagement with an object that consumes light itself forces us to confront the sheer scale of the universe, a scale that is not just vast, but deeply woven with patterns and forces that connect everything, from the smallest particle to the largest cosmic web. Standing under a truly dark sky, your eyes can just barely make out a faint, fuzzy patch in the constellation of Andromeda. That soft glow is the light of 1 trillion stars, a whole other island universe, traveling for 2.5 million years to reach your retina. Galaxies are the fundamental cities of the cosmos, the grandest scales at which we can see the universe organize itself. Each one is a sprawling, gravitational dance of billions of suns, vast clouds of dust, and the mysterious, unseen hand of dark matter. When the astronomer Edwin Hubble confirmed their existence beyond our own Milky Way, he did more than just make a discovery. He gave artists an entirely new canvas, an epic new template for composition on a literally universal scale. The artist's first task is to translate the two-dimensional photograph of a galaxy into a believable three-dimensional structure. A spiral galaxy like the stunning Whirlpool Galaxy is not a flat pinwheel. It is a vast, rotating disk, its arms tracing out waves of density through the stellar population. To create this depth, an artist uses subtle tricks of light and shadow, painting the central bulge of ancient stars as a glowing, three-dimensional ball, and rendering the spiral arms with carefully layered stars and obscuring dust lanes that seem to recede into the distance. Color becomes a language for telling the story of stellar life and death. The cool, blue-white light of young, massive stars illuminates the active spiral arms, while the reddish glow of older stellar populations dominates the central bulge. In a chaotic merger like the antennae galaxies, the palette explodes into a violent symphony of gold and crimson as colliding gas clouds trigger frantic waves of new star formation. And at the heart of nearly every large galaxy, including our own, lies its greatest mystery, a supermassive black hole. Artists depict this not as a void, but by its terrifying influence, a central point of unimaginable gravity around which the entire galaxy slowly spins. We can see a prophetic, emotional interpretation of this galactic motion in a painting from a time before galaxies were even understood. Vincent van Gogh's The Starry Night does not show a realistic sky, but its swirling, turbulent patterns of light feel more true to the dynamic energy of a galaxy than any photograph. The thick, rhythmic brushstrokes in the sky mirror the churning motion of stellar orbits, and the luminous halos around the stars evoke the diffuse light of billions of distant suns. It is a portrait of cosmic energy painted directly from the artist's internal vision. So this leads us to a profound question about every painted galaxy we encounter. Is each one a self-portrait of the artist's own mind? Is the ordered spiral a reflection of a structured, logical thought process, and the chaotic merger an expression of internal conflict or creative upheaval? This macro view of island universes forces us to look inward, to see our own mental landscapes reflected in the grandest structures of the cosmos. An artist stares into the Hubble ultra-deep field, a single pinprick of sky containing 10,000 galaxies, each a swirling city of billions of suns. The mind recoils, then quiets in the face of such a number. This is more than a scientific image, it is a philosophical mirror, reflecting our deepest questions back at us. What is our place in a universe of such staggering scale? Is reality merely the physics of these distant lights, or is it something more, something we can feel but never fully hold? Celestial art has always been an existential quest, a way to grapple with the sublime. The philosopher Immanuel Kant defined the sublime as that which is absolutely great, beyond all comparison. It is the feeling you get not from a pretty flower, but from the storm-tossed ocean or the star-drenched void, a mixture of awe and terror that reminds you of your own smallness while simultaneously elevating your spirit. Art becomes the essential mediator for this overwhelming encounter. It translates the cold, hard data of cosmic distance into a language of human emotion, giving form to our feelings of insignificance, our boundless curiosity, and our profound desire for connection. In this role, the artist becomes a modern-day shaman, an interpreter of the cosmic unknown. They stand between the raw, indifferent universe and the human heart that insists on finding meaning. Their work does not provide easy answers, but instead creates a space for the question to breathe. They search for a glimmer of purpose in the vast, silent machine of space-time, and in doing so, they offer us a tool for a kind of cosmic consciousness, an expanded awareness of our context within the whole. We can see this quest for a shifted perspective in the artistic attempts to recreate the overview effect, the profound cognitive shift reported by astronauts when they see the Earth from orbit. They speak of the world without borders, a fragile, living marble suspended in blackness. Artists on the ground who cannot travel to space strive to evoke this same feeling. They build immersive installations that reduce the viewer to a single point in a sea of stars, or craft images of our planet that emphasize its solitude and beauty. They are trying to gift us from the studio that life-changing glimpse of the whole, so we are left with a deeply personal question to carry forward. Does creating art about the cosmos make us feel smaller or more connected to its vastness? It does both at once. It humbles us with the truth of our physical scale, yet it ennobles us by affirming that we are the part of the universe that has become conscious, the part that can look back at the void and feel its beauty. This philosophical grounding, this search for meaning amidst the galaxies, is not just abstract contemplation. It is the very fuel that ignites the practical, hands-on process of creation. Take a single sheet of paper and try to draw the solar system to scale. You will fail. The sun becomes a microscopic dot, and the outer planets vanish entirely, their orbits extending far beyond the paper's edge. This simple, frustrating exercise reveals a profound truth about the cosmos, one that artists have turned into their most powerful tool for evoking the sublime. Scale is not just a measurement, it is an emotional experience, a way to dwarf the viewer and trigger a deep, humbling awe. The architect and thinker Buckminster Fuller captured this creative spirit perfectly when he said, "I am convinced that creativity is a priori to the integrity of the universe, and that life is regenerative and conformity meaningless." To depict the cosmos is to think beyond human scales, to embrace a regenerative creativity that mirrors the universe's own. So how do artists manipulate this impossible scale? One of the most direct techniques is the juxtaposition of the human figure against a galactic backdrop. A painting might show a lone astronaut, a mere speck, adrift in front of the swirling, stormy face of Jupiter, instantly communicating a feeling of both insignificance and incredible courage. Other artists work in the opposite direction, using microscopic details to suggest cosmic patterns. The intricate branching of a lightning bolt or the delicate structure of a snowflake can be rendered to echo the vast, web-like structure of the universe itself, connecting the infinitely small to the infinitely large. And then there are the room-sized installations that immerse you completely. You walk into a dark space where the entire floor is a high-resolution map of the Martian surface, or the walls are a projection of a nebula so vast you feel you could fall into it. This physical immersion makes the cosmic scale something you do not just see but feel in your bones. In the realm of data art, logarithmic scales become essential. An artist might create a visualization where each step represents a tenfold increase in size, from a human hand to the solar system to the local galactic cluster, all in one continuous, mind-bending image. The psychological impact of this perceived immensity is the entire point. It is meant to overwhelm your everyday sense of self, to trigger that quiet, philosophical awe that comes from confronting the true proportions of reality. The masterwork that inspired generations of artists in this endeavor is Charles and Ray Eames' classic film, Powers of 10. In just 9 minutes, the camera pulls back from a picnic on Earth to the edge of the known universe, and then zooms back into the level of atomic nuclei. It is a perfect, elegant demonstration of cosmic order, a visual poem that makes the abstract concept of an exponent into a breathtaking journey. It teaches us that to understand the universe, we must constantly shift our perspective. So how can you use scale in your own work to tell a cosmic story? It begins with challenging your own perceptions of size and distance and finding those powerful contrasts that make the heart skip a beat. This technical mastery of proportion, however, is inseparable from the artist's next essential consideration, the vibrant and often unnatural language of color. The artist mixes another dab of magenta into the pale ochre, chasing a color that has never existed in any earthly sunset, the dusty, rosy pink of a Martian twilight. This quest for the perfect cosmic hue reveals a second great impetus for creation, the challenge of building an entire visual language from the light of distant worlds. Color in celestial art is never arbitrary. It is a powerful emotional and symbolic language, one that bridges the gap between scientific data and raw human intuition. A color theorist might explain that we are essentially translating specific wavelengths of electromagnetic radiation into a palette of human feeling. The deep crimson of an emission nebula rich with hydrogen alpha light can be coded to evoke both the warmth of creation and the heat of destruction. That specific frequency of red becomes more than a data point, it becomes a character in the story. The artist's palette is thus a map of the cosmos itself. The profound blacks and violets of empty space are not merely an absence, but a positive presence, a velvety backdrop that makes the stellar fires pop with life. The fiery reds and oranges of stellar nurseries speak of violent birth and immense energy, while the ethereal blues and greens of planetary auroras suggest magnetic dances and otherworldly atmospheres. And then there is the blinding, complex white of a star, which is not one color but the sum of all colors, a challenge to represent without flattening its brilliance. To capture this luminous quality, artists turn to specialized materials. They mix luminescent and iridescent paints that absorb and re-emit light, creating a faint, internal glow on the canvas that mimics the radiant energy of a distant sun. In the digital realm, they create custom gradients, painstakingly building transitions from the cool blue-white of a young star to the deep red of a carbon star, ensuring every celestial object has its own unique spectral fingerprint. This interplay between data and artistry is beautifully illustrated by the James Webb Space Telescope. Its first images, rendered in infrared light invisible to our eyes, presented the universe in a palette of deep golds, rusty ochres, and muted coppers. Almost overnight, artists around the world began incorporating this new, ancient golden hue into their work, adopting the telescope's data-driven vision as their own. This practice forces a compelling philosophical question. If we are seeing the universe through false color, through a translation of invisible light into visible spectrum, is the artist's emotional interpretation any less real than the scientific data? Perhaps it is simply another way of seeing, another valid layer of truth. This intricate dance of color, this visual language of the cosmos, is never static. It is always in motion, a fluid dynamic that leads our eye across the canvas and our mind through the story of the universe itself. A time-lapse video of the night sky reveals silent, swirling rivers of starlight, a grand illusion of motion created by our own spinning planet. This celestial dance points to the artist's third great challenge, capturing the relentless motion and unimaginable timescales of the cosmos within the static confines of a canvas or the brief window of a film. The universe is never still. Galaxies rotate in a slow, million-year waltz, stars are born in violent collapses, and the very fabric of space expands, stretching the distances between everything. The physicist Brian Greene described this kinetic reality perfectly, noting, "The universe is a symphony of strings and the cosmic landscape a vibrating string." How can an artist possibly score this symphony onto a flat, motionless surface? They have developed a sophisticated visual language to imply motion where none exists. A blurred brushstroke behind a streaking comet gives it velocity. A series of sequential images, like frames from a film, can show the gradual orbital dance of a binary star system. Sculptors build kinetic mobiles where polished spheres orbit a central core in a slow, silent ballet, making the abstract principles of orbital mechanics tangible. In digital art, animation brings the cosmos to life, allowing us to witness a supernova unfold over centuries in a few seconds or fly through a nebula as its gases churn. The early 20th century futurists were pioneers in this quest, not of space but of speed itself. Their paintings of racing cars and bustling cities fragmented light and form into dynamic lines of force, attempting to paint velocity and energy itself. This artistic revolution was a crucial precursor, developing the techniques later artists would use to depict the spin of a galaxy or the explosive shockwave of a dying star. To illustrate the expansion of the universe, an artist might paint galaxies not as isolated islands, but as dots on an inflating balloon, each one receding from the others as the space between them grows. Depicting the life cycle of a star requires compressing billions of years into a single narrative image, showing a stellar nursery, a mature sun, and a planetary nebula all as stages in a continuous, flowing arc. The most difficult concept of all is space-time curvature, the warping of the cosmic fabric by mass. Here, artists use warped grids and stretched starlight around a dark central mass to make this invisible force visible. This entire endeavor forces a profound question. How do you paint a billion-year process on a canvas that will last a century? You paint not the years, but the feeling of the process, the energy of transformation itself. This engagement with deep time connects directly to the modern digital tools that make visualizing these epic journeys possible. A sleek tablet glows beside a laptop, its screen a tangle of astronomical data and open software windows. This is the modern celestial artist studio, a hybrid space where the tactile feel of a digital stylus meets the computational power of astrophysics. The tools of the trade have expanded into an entire ecosystem, bridging the gap between the observatory and the canvas. One digital creator notes that software like Adobe Creative Suite, Blender, and Unreal Engine has effectively democratized cosmic art. What was once the domain of a few specialists with access to supercomputers is now available to anyone with a passion and a personal computer. This technological shift has unlocked a new creative stratum. The artist's toolkit is now a layered palette of the physical, the digital, and the informational. Traditional media like oil paint, charcoal, and pastels remain vital for their raw, expressive texture, perfect for capturing the emotional turbulence of a nebula or the soft glow of a distant galaxy. Yet these now coexist with powerful digital suites that allow for impossible precision. Artists can use three-dimensional modeling software to construct entire star systems, applying complex shaders to simulate the light-scattering properties of cosmic dust or the plasma arcs of a solar flare. The raw material for this art is often free and public, streaming in from the archives of NASA, the European Space Agency, and the Jet Propulsion Laboratory. These vast repositories of telescope imagery, spectral data, and planetary topography provide a universe of reference material. The tools for interacting with this data have also evolved. An artist might don a virtual reality headset not just to experience the cosmos, but to create within it, painting three-dimensional nebulae in an immersive, room-scale void. They can feed data into a three-dimensional printer to produce a tangible, physical model of a distant asteroid, making the abstract tactile. For the more technically inclined, programming languages like Python become a new kind of brush. An artist can write a script that automatically pulls real-time data from a satellite monitoring solar wind, using that live information to control the color and motion of a generative artwork that pulses and flows in rhythm with the sun's activity. The piece is never static, it is a living collaboration with a star. This incredible accessibility forces a compelling question. As our tools grow more powerful, blurring the line between simulation and creation, what truly drives the art? Is it the artist's unique vision and emotional intent, or is it the sheer capability of the technology, suggesting forms and possibilities the human mind might not conceive alone? The answer likely lies in the synergy between them, where the artist's wonder guides the machine's infinite potential. A teenager in a remote village points a smartphone at the night sky, and an app overlays the ancient constellations in glowing lines. Hours later, that same person shares a vibrant digital painting of Orion, created on a tablet and seen by thousands across the globe before the real constellation has even set. This is the new reality of celestial art, a field fundamentally reshaped by the internet and digital technology. These tools have become the great equalizers, demolishing the old barriers of geography, resources, and institutional access. Suddenly, the raw materials of the cosmos, high-resolution imagery from the world's greatest telescopes, and the vast data sets they produce, are a free public library for anyone with a connection. Digital culture scholar Clay Shirky identified this shift as a harnessing of our cognitive surplus, where connectivity fuels a massive, collective creativity. People are no longer just consuming media, they are pooling their time, talent, and passion to build something new together, and space art is a stunning example of this global collaboration. Online platforms have become the primary galleries for this movement. Instagram, DeviantArt, and Behance are now vast, interconnected museums dedicated to the heavens, hosting millions of works from creators at every skill level. These are not just passive archives, they are vibrant communities. An artist in Brazil can post a work in progress of a nebula and receive immediate, constructive feedback from a seasoned professional in Japan. A beginner can watch a time-lapse tutorial on YouTube, learning how to use free, open-source software like GIMP or Blender to model a three-dimensional galaxy. Crowdfunding platforms allow these distributed communities to rally behind ambitious art science projects, funding everything from large-scale installations to independent data visualizations that might never find traditional support. The sheer scale of this creative explosion is visible in a single hashtag. Searching for space art on any social media platform reveals a torrent of thousands of new works every day, a living, breathing archive of celestial inspiration. Here, a hyper-realistic digital painting of Jupiter by a retired engineer sits beside a whimsical, animated GIF of an alien sunset by a high school student. This aggregation creates a global conversation, a continuous stream of interpretation and reinvention that pushes the entire genre forward. It forces us to ask, has the digital age truly made everyone a potential cosmic artist? The tools and the audience are now undeniably in place, inviting a new generation to look up and translate what they see. This collective, communal act of creation naturally opens a door, transforming personal expression into a powerful vehicle for public learning and wonder. A classroom of fifth graders is not just looking at diagrams of the moon's phases, they are shaping them from clay with their own hands, painting the craters of the Sea of Tranquility in shades of gray and white. This fusion of science and art is transforming abstract astronomical concepts into something tangible, something a student can literally hold. Celestial art has become a powerful engine for STEM education, bridging the gap between cold data and warm human understanding. An experienced science teacher will tell you that when a student builds a model of the solar system or paints a nebula, the information moves from a temporary fact to a lasting memory. The physical act of creation forges a deeper, emotional connection to the subject, dramatically increasing both engagement and long-term retention of complex ideas. Educational methodologies are now fully embracing this interdisciplinary approach. To visualize an invisible force like gravity, students might create collaborative mobiles with planets suspended by strings, their orbits a physical manifestation of gravitational pull. To overcome the math anxiety often associated with physics, they code simple animations of orbiting planets, where the artistic outcome depends on correctly inputting the mathematical principles of velocity and mass. These projects make the math feel less like a barrier and more like a creative tool. Many schools are launching artist-in-residence programs, bringing painters and digital creators into the classroom to collaborate with science teachers, showing students that the same mind that wonders about the composition of a star can also express its beauty. One powerful example is a school-wide project to paint a massive mural of the Milky Way along the entire length of a main hallway. As students walk to class, they are physically journeying from the galactic core through the spiral arms and out toward the sparse outer halo, their daily commute an immersive lesson in the structure of our home galaxy. This layered, sensory learning experience forces us to ask a compelling question about the future. Could the next great astrophysicist be inspired not by a textbook, but by the feel of clay or the stroke of a paintbrush? The future of cosmic discovery may well be painted in these vibrant, collaborative classrooms, where the lines between science and art beautifully blur. A visitor dons a headset and suddenly floats in the void, the 7 rocky worlds of the TRAPPIST-1 system orbiting a cool red sun within arm's reach. This is not a game or a documentary, but a new form of celestial art, a scientifically grounded simulation crafted by an artificial intelligence. We are entering a new frontier where the canvas is virtual space and the collaborator is a non-human intelligence. As digital artist Rafik Anadol suggests, we are moving from artists using machines as tools to artists collaborating with the algorithms as creative partners. This partnership is birthing forms of cosmic expression that are fundamentally alien to human imagination. Emerging trends are already reshaping the artistic landscape. Advanced AI models are being trained on millions of images from the Hubble and Webb telescopes, learning the visual language of nebulas and galaxies so they can generate entirely new ones, cosmic objects that have never existed but feel hauntingly real. Virtual reality galleries are being constructed not on solid ground, but in simulations of zero-gravity environments, where sculptures of dark matter can be viewed from every angle and paintings can expand into infinite, walk-through starfields. Augmented reality apps on your phone can now overlay the real night sky with detailed information and artistic interpretations, turning a simple glance upward into an interactive celestial exhibition. These new tools raise profound ethical questions about authorship. If an AI generates a stunning image of a supernova based on a simple text prompt from a human, who is the true creator? The debate intensified when an AI-generated portrait sold at a major auction house for over $400,000, signaling a seismic shift in how we value art and creativity. The potential extends beyond the visual into fully immersive, multi-sensory experiences. Future artworks might simulate the vibration of a pulsar through haptic suits, or fill a room with the scent of cosmic dust based on spectral data. Some art is already abandoning physical form altogether, existing purely as code in decentralized digital realms, accessible only through specific software and destined to evolve over time. This leads to an inevitable and thrilling question. Will the future of cosmic art be something we simply look at on a wall, or will it become an entire universe we can physically step into and inhabit with all our senses? This forward-looking perspective brings the vastness of the cosmos directly to you. You do not need a telescope or a physics degree to start creating celestial art. You just need to look up and feel. The universe is already your canvas, waiting for your personal translation. The artist Pablo Picasso offered a vital key to unlocking this process when he said, "Inspiration exists, but it has to find you working." The most important step is always the first one. Begin with the sky itself. Go outside on a clear night, find a comfortable spot, and simply watch. Do not just look, but observe. Notice how the moon's light silvers the edges of clouds. See if you can detect the subtle color differences between stars, the warm orange of Betelgeuse versus the cool blue of Sirius. Keep a small journal, not for perfect drawings, but for your raw impressions. Write down a single word that captures the feeling of the vastness, or sketch the rough pattern of a constellation that catches your eye. This act of mindful observation is the foundation upon which all cosmic art is built. Next, make the moon your first muse. Its ever-changing face is a perfect, forgiving subject. You can track its phases over a month with a series of simple sketches. You do not need expensive materials for this. A soft charcoal stick and some textured paper can capture the dramatic shadows of the craters. A basic set of watercolors is perfect for experimenting with the soft, ethereal glow of moonlight on a landscape. If you are drawn to digital tools, there are fantastic free painting apps available for your tablet or computer. Pair one of these with an inexpensive graphic tablet, and you have a complete digital studio to start painting nebulae and planets. Do not aim for a masterpiece on your first try. The goal is to play, to explore, and to learn how different tools behave. Another powerful step is to connect with others on the same journey. Seek out online space art communities on platforms like Reddit or Discord. These are incredibly supportive spaces where you can share your early attempts, ask for gentle feedback, and be inspired by what others are creating. You will discover a global family of creators all looking up at the same stars. For an endless well of inspiration, you have the entire cosmos at your fingertips through free resources like NASA Image Archive. Download a stunning high-resolution photo of the pillars of creation or the swirling storms of Jupiter. Try to recreate its colors with your paints or use it as a reference to understand the structure of a galaxy. Study how the artists at NASA use color and composition to tell a scientific story, and let that inform your own artistic choices. Consider starting with a simple, personal project, like a painting of your favorite constellation placed over a landscape that is meaningful to you. One artist began by casually doodling ringed planets in the margins of her work notebooks during her lunch break. She posted these simple sketches online, and the positive feedback encouraged her to keep going. She practiced daily, studying the brushwork of established space painters, and over time, those small doodles evolved into a vibrant, unique style celebrated by thousands of followers. Her journey started not with a grand plan, but with a single, curious mark. So, with a journal in your hand and your eyes on the sky, what part of the universe is waiting for your interpretation? That single, pale blue pixel from 4 billion miles away contains within it the entire story we have just witnessed, from the star maps in prehistoric caves to the code-generated galaxies of a digital screen. This enduring dialogue between humanity and the heavens is not merely a chronicle of artistic subjects. It is the story of the universe itself becoming conscious, using human hands and minds to reflect upon its own staggering beauty and mystery. Space has never been a passive subject to be copied. It is an active, dynamic partner in the creative process, a relentless force that constantly shatters our artistic tools and demands we invent new ones. It challenges the painter to mix a color for vacuum, the sculptor to give form to nothingness, and the composer to find the melody in absolute silence. The poet Rainer Maria Rilke once offered a luminous insight that applies perfectly to this cosmic struggle. He wrote, "Perhaps all the dragons in our lives are princesses who are only waiting to see us act just once with beauty and courage." The immense, terrifying dragon of the cosmic void, with its black holes and unimaginable scales, is not an enemy to be slain. It is a profound mystery waiting for us to approach it with the courage to create, and in that act of bravery, it transforms into a source of unimaginable beauty. Our journey reveals several profound truths about this relationship. We have seen its deep historical roots, how the human impulse to chart the stars is as ancient as art itself. We have witnessed the powerful symbiosis with science, where the artist's vision and the physicist's equations illuminate the same truth from different angles. We have explored the revolutionary power of new technologies, from the photographic plate to the algorithm, each one expanding the artist's palette to include the very light and data of the cosmos. And most importantly, we have seen that cosmic inspiration is now accessible to everyone with a curious mind, a smartphone, or a simple stick of charcoal. The ultimate impact of this celestial art is both emotional and philosophical. Creating and viewing these works is how we navigate our place in the grand scheme. It is how we practice the overview effect here on the ground, reminding ourselves that we are both insignificantly small and miraculously rare. This dialogue between art and the cosmos is one of humanity's most enduring and evolving conversations. A conversation that began with a story told around a fire about the shapes in the night sky and continues now in the silent hum of a server farm rendering a new universe. That fragile, pale blue pixel contains the entire story, from prehistoric star maps to galaxies born from code. This journey reveals that celestial inspiration is far more than a theme. It is a unifying force in human creativity, a constant thread connecting the first artist who looked up in wonder to the latest digital creator painting with artificial intelligence. The cosmos fuels art by offering an infinite well of mystery, a scale that dwarfs our imagination and, above all, a profound mirror for our own humanity. Every nebula painted and every black hole visualized is ultimately an attempt to process the universe, to understand our place within it not just intellectually, but on the deepest emotional level. We use art to build a bridge across the terrifying void, finding connection in the grand, silent machinery of space. The astronomer Neil deGrasse Tyson offers a perfect reflection on this relationship when he says, "We are part of this universe, we are in this universe, but perhaps more important than both of those facts is that the universe is in us." The iron in our blood, the calcium in our bones, every element that makes our life and our art possible was forged in the hearts of long-dead stars. When we create celestial art, we are not just painting the heavens, we are painting with the very stardust of our own origin. We are the universe contemplating itself. This dialogue is an invitation to you. Do not let it end with this video. Become an active part of this ancient conversation. Seek out the work of space artists in galleries and online. Support their mission to bring the cosmos closer, and consider starting your own